Aikal bin Haizan. My metric number is 08DEP21F1075.
My name is Manjatu Akmal binti Muhammad Asri and my metric number is 08DEP21F1061.
Hi, my name is Nur Anis binti Abdul Ghani. My matrix number is 08DEP21F1064.
My name is Nur Atika binti Arifin and my metric number is 08DEP21F1059.
So, let me explain a little bit about differentiation. Definition of differentiation is a method of finding the instantaneous rate of change in function based on one of variables. In contrast to the abstract nature of the theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulation. So, three basic derivatives are for algebraic function, trigonometric function, and exponent function. Next, for application of differentiation. Differentiation is widely used in science and engineering field. It can help us solve many types of real-world problems. Some applications of differentiation include Newton's method, rate of change, and finding minimum points and curve sketching. Differentiation allows us to discover and apply the constant used in all areas. Like example is to check the temperature variation, to determine the speed or distance covered, such as mile or kilometer per hour.
Okay, now I want to talk about stationary points. Okay, we must understand that stationary points only occurs when dy over dx equal to 0. Next, we must apply a second order derivative to determine stationary points is a maximum point, a minimum point, or a points of inflection. Okay, there is three types of stationary points, that is minimum point, maximum point, and points of inflection. Okay, to determine the stationary point, we must know if d square y over dx square more than 0, it is minimum point. If d square y over dx square less than 0, it means maximum point. And lastly, if d square y over dx square equal to 0, it is mean points of inflection. Here are the steps in sketching a curve.
So the question is y equals 2 plus 3 x square minus x square 3. So using the formula, dy per dx equal 6x minus 3x square. At stationary points, dy per dx equal to 0. Okay, equal to 0. This means 6x minus 3x square equals to 0. After that, we must to factorize the 6x minus 3x square equal to 0. Then we get 3x in bracket 2 minus x equal to 0. Ni after we factorizing, we get the answer 3x in bracket 2 minus x equal to 0. Then we know the 0 is the x is equal to 0 or x equal to 2. From 1 in bracket, we know d square y per d per x square equal 6 minus 6x, which is positive when x equal to 0 and negative when x equal to 2, and x into y equal 2 plus 3x square minus x square. And we know the x equal to 0 give y equal to 2, and x equal to 2 give y equal to 6. And this the point which is we must to plot into the graph. So we know in bracket 0, 2 is a minimum point, which is a minimum point. Okay, we're gonna look to the graph after this. And 2, 6 is a maximum point, which is okay, this is the graph when x equal to 0, y equal to 2, and when y equal to 0, which is 2 plus 3x square minus x square 3 equals 0. So this is a graph which is the x point, y. So the graph look like this because you read this 0, 2 is a minimum point. So this is a minimum point for the graph. This is minimum point. Okay, minimum point. And this 2, 6 is a maximum point from the graph. This is a maximum point of the graph. Okay.
What is rate of change? Rate of change function is defined as the rate at which one quantity is changing with respect to another quantity. In simple terms, in the rate of change, the amount of change in one item is divided by corresponding amount of change in another.
Let's discuss an example question of rate of change. If radius of curve increased at the rate of 5 cm square, find the rate which the area is such when the radius of the circle is 10. Okay, let's find the solution of this question. Firstly, we should take out all the information from the question. We have dr over dt equal to 5 cm, and then we have r, which is radius of circle 10 cm, and lastly we have to find out what the answer of dA over dt. Next, we should know what the area of circle. The area of circle is A equal to pi r square, and then we should differentiate that formula, which dA over dr equal to pi r. Next, dA over dt equal to dA over dr times dr over dt, so that we get 2 pi r times 5 equal to 10 pi r. Lastly, we should put the radius of the question into the formula, which is dA over dt equal to 10 pi times 10, so that we get 100 pi cm square per second. That's the solution of the question.